Hello. This will be a quick demo and walkthrough of NanoKeys, a library that transforms a BLE Nano into a wireless Bluetooth Low Energy keyboard. First off, let's see it in action. The Nano, on the right, is running the AutoKeys example from the library. You pair with the device just like any other Bluetooth keyboard through the standard interface on the mobile or tablet. Once that's done, just sit back and receive keystrokes. Booyah! Okay, this will be a quick walkthrough of coding for the NanoKeys library. As you'll see, the library handles most of the details, so it's all pretty simple. Now, the first thing we need is to include the library. So here we go, the BLE library and the NanoKeys itself. Now we're going to interact with two main components, the manager, which handles all the meta stuff like BLE setup, and the keyboard itself. So we declare the keyboard as a global. So it's in the NanoKeys namespace. It is a keyboard, keybeard, the keyboard. The other thing we're going to need from the BLE library is a ticker. This is just a periodic task that's going to wake us up once in a while. We also need a callback for that guy, so wake me up. You could do some stuff in here, whatever you like. Just I treat it as an interrupt, so nothing too complex, but we don't actually need anything except the waking up part. In our setup, you'll do whatever else you need, but the two things we need for NanoKeys are to get the manager singleton, there we go, and call its begin with one parameter, the name we're going to be broadcasting. So whatever you want, just not too long there. The other thing we need to set up is the ticker task, so it'll wake us up once in a while. So we attach, call the wake me up function. Every 50,000 microseconds. So every 50 milliseconds we're going to call wake me up here and do nothing. In the main loop, okay, I'm going to keep track of how often we get called with this variable. And the idea here is that every time we get called, let's say 10 times, we're going to print something. Now the keyboard actually uses the same print interface as serial, so you can do everything you're used to doing with that. So hello, this is print number, so that was a string, and here we go, print line, print count. Now we're pretty much done. Except for one thing. If we do this, we're going to be printing and like crazy on the keyboard. So that's one of the reasons we use the print count. The other is we need to sleep a little bit between calls, and to find a way to handle all these BLE events, the ticker and anything that might be incoming, like registration, pairing, all that. So for that, we get the manager again. And simply wait for event, which is just a wrapper around BLE wait for event anyways. So the way it's going to work is it'll enter the loop, print count plus plus, it won't, no, this will pass over, wait for event. The first event we're probably going to get is the ticker task, which will do nothing, but it'll wake us up and it'll force the loop to go through again. If we're paired and connected, then the actual keyboard print calls will actually emit notifications through the HID specification, and that's pretty much it.